In today's lesson, we are going to continue working with multi-step absolute value equations. So let's go over some of the key features that we need to know in order to apply on solving and graphing these inequalities. So we know that in order to solve an inequality, we need to make sure that we break them down into two separate situations or two separate equations. And we know that when we look at an inequality like the absolute value of b minus 2 is less than or equal to 6, if we simply rewrite the equation b minus 2 is less than or equal to negative 6, that is one of the situations. In this example, we are just removing what appears to be the absolute value bars. That is our first equation. Our second equation, when we break down our absolute value inequality, is to go ahead and write the contents within the absolute value bars, but instead of writing less than or equal to, we flip the direction of that inequality symbol into greater than or equal to. And in order to close this equation, this inequality, we are going to change the sign of that value. This was 6, so it's going to be a negative 6. So when we're breaking down inequalities, we are changing it into two separate situations that we can solve and graph for their solutions. We also need to review what it means to apply certain plotting values. So when we see an expression with an inequality symbol that looks like a greater than or equal to or a less than or equal to, we know that when we plot our values, we're going to use a closed circle. This is going to be closed. And a closed circle is going to have a dot on the value that we want to graph. In contrast, if we have inequality symbols that lack that equal to expression, for example, greater than or less than, then we're going to have an open circle. The reason why we have an open circle is this idea of being exclusive. We want to solve for all the values besides the one that is expressed in our inequality. So it's open means that we don't include that value. For example, if we have x is greater than 6, we want all the values that are greater than 6, but we don't want 6 because 6 would be equal to 6 rather than greater than. So that's why that circle would be open. We also want to understand which direction we want to graph. So let's go ahead and give ourselves a random value, and I'm just choosing randomly. One is an open circle, and the other is a closed circle. So if you see that your expression or your inequality is less than or equal to, or just simply less than tells you that you have to move left. So wherever your value is, your plotted value, you want to shade everything to the left. That is your less than inequalities. In contrast, on the opposite, if you have greater than or equal to, or simply greater than, you want to shade in or graph all the values that are true going to the right side of that value. So greater than or equal to and greater than are moving in the right direction. So let's go ahead and apply some of those concepts to an actual inequality. So there are two situations that we have, just like we did when we were working with absolute value equations. Absolute value inequalities are going to share some of the same things. So we have absolute value inequalities with an entire expression inside the absolute value bars. Notice we have these two long bars and everything is contained inside it. So we have h plus 2 divided by 3 is greater than 6. Notice nothing changed from this equation. All I did was remove those absolute value bars. The second expression that we have is h plus 2 divided by 3. And we change the sign, so since it was greater than, it becomes less than. Notice how they're pointing and opening in opposite directions. And the value of 6 is also going to be opposite, so it's going to be negative 6. And we know that this is true is because if we visualize the solution to this expression inside the absolute value, we know that in order to have a distance, which is what absolute value measures, that is bigger than 6, then we need to look at all the points that are more than 6 units away from 0 in the left direction or the negative direction, and all the values that are 6 units away from the 0 in the right direction or the positive direction. So that's how we arrived at these two equations. And when we solve these two equations out by using inverse operations, and this is multi-step, so the inverse operation would be to multiply by 3, and then we're going to subtract 2. So when we do that, when we multiply 3 and subtract 2, we're going to get h is greater than 16. 3 times 6 gives us at the 18. When we subtract 2, we get 16. And then when we multiply this by 3 and then subtract 2, we'll get h is less than negative 20. We have these two expressions, and then we can go ahead and graph them. The other situation that we have is when some parts of that inequality is on the outside. And the key thing to expressions that have parts that are on the outside is we need to make sure that we isolate or keep this part of the equation with the absolute value by itself. So in order to do that, we need to use inverse operations to get rid of the parts that's not inside the absolute value bars. So the part that isn't inside is that 10, that positive 10. So the inverse would be a negative 10. So the absolute value of r divided by 4 is greater than 5. Now that we have this equation, this inequality, we can just separate them into two situations. So it's r divided by 4 is greater than 5. Again, notice how I just took away the absolute value bars. And my second situation is r divided by 4. That inequality symbol flips direction, and that 5 becomes a negative 5. So when we solve this, we have r is greater than 20, as well as r is less than negative 20. And then we just go ahead and graph those two solutions. The next part of our practice is to look at the absolute value of 2m plus 8 is less than or equal to 16. So the first step to ask is, are there parts on the outside of the absolute value bars? The answer is no. So then we can just go ahead and break them down into those two separate inequality situations. So we have 2m plus 8 is less than or equal to 16. And we have 2m plus 8, switch the signs in the direction, would be greater than or equal to, and negative 16. Again, the symbols are opposite directions, and the two values that they're set to are opposite signs. So then when we apply the multi-step inverse operations to find the value of m, we should subtract by 8 and then divide by 2. So we should get an answer of m is less than or equal to 4, because 16 minus 8 will get us 8, divided by 2 will get us to 4. And similarly, if we apply it to this one, we should get m is greater than or equal to negative 12, because negative 16 minus another 8 is going to give us negative 24, divided by 2 is going to give us negative 12. Then on our line, on our number line, we can then go ahead and make our reference of 0. 4 is going to be on the right of that. Negative 12 is going to be on the left. Since our expression includes that equal to expression, we're going to do closed circles. And then we're going to ask ourselves, what are the directions that we're moving in? Less than means that we're moving in the left direction. and greater than means that we're moving in the right direction. So the values that exist between negative 12 and 4 are the solutions that would make this statement, this inequality, true. Go ahead and try this problem on your own. It's your turn. Thinking about 1, are there parts that are on the outside? So if there are, we need to make sure that we need to solve those parts first. The second step would to identify the two situations, those two inequalities. Once we identify our two situations, we can then go ahead and solve. Once we solve for our two separate inequalities, we can then go ahead and graph. And we also want to graph it on this number line. So go ahead and take a moment to solve this equation. I want to change this problem. This should actually be a greater than or equal to. It's an inequality, not just an equation. So make sure you change your symbol before you start solving. And then once you're done with that, let's see if you can challenge yourselves with this multi-step equation, this inequality. Good luck.